Hello and welcome to the Master Civil Engineering. In this video we will learn how to calculate pressure difference using a manometer. We will be solving three different questions so that we will have a better understanding of the procedure to find pressure using a manometer. The first question is shown, and in this case we have to calculate the pressure difference between point A and B, given that the H1 is equal to 0.5 meter, H2 is equal to 0.9 meter, and H3 is equal to 0.6 meter. The unit weight of liquid first, that is gamma 1, is equal to 9.81 kilonewton per meter cube, gamma 2 is equal to 133.42 kilonewton per meter cube, and gamma 3 is equal to 19.62 kilonewton per meter cube. The procedure to find the pressure using a manometer is that we will be starting with the pressure at A in the tank and moving along the tube by adding as we go down or subtracting as we go up the gamma H terms until we reach the point B and setting the result equal to pressure at B. So starting with the pressure at A, we have PA, and then moving in the downward direction, that is plus gamma 1 into H1 until we reach point 2. From point 2 to point 3, the liquid in the left and the right limbs of the manometer will be balanced, so this portion will be ignored, and we will be measuring pressure from point 3 to point 4. Since we are moving in the upward direction, the pressure would be negative, so it will be minus gamma 2 into H2 until we reach the point 4. From point 4 to point 5, again the pressure will be negative, so it will be minus gamma 3 into H3 until we reach the point B, that is equal to PB. Putting the values of unit weights and the heights of the liquid and solving the above equation, we get the pressure difference between A and B equal to 126.95 kilopascal. Again, in the second question, we have to calculate the pressure difference between points A and B. And in this case, the fluids are benzene, air, mercury, kerosene, and water with their unit weight shown. So we will be again starting with the pressure at A and moving along the manometer until we reach the point B. So starting with the pressure at A, we have PA plus unit weight of benzene, that is gamma B into 0.2 until we reach the point 2. From point 2 to point 3, this portion will be again ignored as pressure in the left and the right limbs will be balanced. So we will be measuring pressure from point 3 to point 4, and it will be negative since we are moving in the upward direction. The liquid in this portion is mercury, so it will be minus gamma M into 0.08. From point 4 to point 5, the liquid is kerosene and we are moving in upward direction, so it will be minus gamma K into 0.32. After that we will reach point 5. From point 5 to point 6, the liquid is water and we are moving in downward direction, so it will be positive, that is plus gamma W into 40 minus 14 centimeter, which will be equal to 26 centimeter or 0.26 meter. So it will be plus gamma W into 0.26. Then we will reach point 6. From point 6 to point 7, the liquid or fluid is air and we are moving in upward direction, so it will be minus gamma A into 0.09 until we reach the point B. So we will be setting the result equal to PB. Putting the values of unit weights and solving the above equation, we get the pressure difference between A and B equal to 8.9 kilopascal. In the third question, it states that the water in a tank is pressurized by air and pressure is measured by a multi-fluid manometer as shown in figure below. The tank is located on a hill where the atmospheric pressure is 85.6 kilopascal. Determine the air pressure in the tank if H1 is equal to 0.1 meter, H2 is equal to 0.2 meter, and H3 is equal to 0.35 meter. The unit weight of water, oil, and mercury are 9.81 kilonewton per meter cube, 8.34 kilonewton per meter cube, and 133.42 kilonewton per meter cube respectively. Again, we will be starting with pressure at point 1 at the air water interface and moving along the tube by adding or subtracting the gamma s terms until we reach the point 2 and setting the result equal to atmospheric pressure, since the point 2 is open to atmosphere. So starting with the pressure at A, we have P1, then moving downwards we have gamma W into H1 as the pressure, as the liquid in this portion is water, until we reach this point. From this point up to this point, pressure in the left and right limbs will be balanced, so it will be ignored. So pressure would be measured from this point, that is plus gamma oil into H2 until we reach this point. From this point to this point again the pressure would be balanced and it will be ignored. So we'll be measuring from this point up to point 2. Since we are moving in upward direction, it will be minus gamma m into H3, and finally the result would be set equal to atmospheric pressure. Putting values of unit weights and solving the equation, we get the pressure at point 1 equal to 129.65 kilopascal. So this represents the procedure how to calculate pressure using manometers. Hope you guys learned something from this video, and if you find this video helpful, please subscribe to my channel and share this video. Thanks for watching and see you in the next video.